Hello everyone, welcome to this session. My chapter is composed of metals, and we are discussing about the metal hydroxides. So, in our previous video, we saw the various these kinds of metal hydroxides. Uh, so today, let's move on to the other part, whereby we'll be talking about the various properties. We are talking about the chemical properties of the metal hydroxides. So in this particular case, the chemical properties of only a few common hydroxides will be discussed. So we'll cover up the various chemical properties of some of the common hydroxides. Starting with the first one, the chemical properties of the sodium hydroxide and the potassium hydroxide. Now, when you heat it together with the aluminium, zinc, and the lead metals, the concentrated sodium hydroxides, they dissolve uh, these metals to form the sodium aluminate, zincate, and the plumpate respectively. As you can see in the reaction, take an example. The first one, aluminium plus sodium hydroxide plus water, leads to the this uh, sodium aluminate plus hydrogen gas. The same goes to zinc plus sodium hydroxide plus water leads to sodium zincate plus hydrogen gas. The same goes to lead plus sodium hydroxide plus water leads to this sodium pumpate plus hydrogen gas. So that's the first chemical property whereby this the the concentrated sodium hydroxide when they dissolve or when heated together with these uh, elements, aluminium, zinc, and the lead metals, they dissolve these metals just to form the sodium aluminate, zincate, and the plumpate respectively. Now, the alkalistic alkalis, they react with the soluble salts of the certain metals like copper, lead, zinc, and iron to form their insoluble hydroxides by double decomposition. As you can see in the reactions here, sodium hydroxide plus this aqueous solution leads to this iron hydroxide plus the sodium chloride. The same goes to the when this also alkalistic alkali when it reacts also with the other soluble salty. You are talking about this zinc sulfate will lead to zinc hydroxide plus this sodium sulfate. So as from the various these two examples, as we've said that the alkalistic alkalis when they react with this soluble. So alkalistic alkalis, we are talking these two. So these alkalistic alkalis, we are talking about these two. Now when they react with soluble salts of certain metals, take an example, the copper, the zinc, the lead, and the iron. From here, take an example, we've seen this iron three and this zinc sulfate, these two. So when they react, they just lead to formation of this insoluble hydroxides. We are talking about this iron hydroxide and the zinc hydroxide uh, through the process of the double decomposition. Hope that's clear. Now, sodium hydroxide also it liberates ammonium gas from the ammonium source when both are warmed together. This is the standard test for an ammonium salt. So as you can see here, uh, this ammonia when ammonia gas when it reacts with the sodium hydroxide it leads to the sodium chloride plus the water plus the ammonia. So that's this the other way or just the other chemical property of the hydroxides. So this specify the sodium hydroxide as it liberates this ammonia gas from the ammonia salts when both are warmed together. Now let's move on as this is the reaction of the sphere. Now when carbon dioxide is bubbled through the aqueous solutions of the caustic alkalis, the carbonates are formed with excess of the gas. The hydrogen carbonates are also formed. As you can see from the reaction, sodium hydroxide plus carbon dioxide gas. This carbon dioxide gas is to this sodium carbonate plus water. The same goes to this sodium carbonate plus water plus carbon dioxide is to sodium hydrogen carbonate. Now, chlorine also reacts with the excess of the co-dilute caustic alkalis to form the hypochlorites, uh, such of the sodium hypochlorites and the potassium hypochlorites. As you can see from the reactions, two of them, the sodium hydroxide plus chlorine, uh, leads to the sodium chloride plus this sodium hypochlorite plus water. The same goes to this potassium hydroxide, reacts with this chlorine, leads to potassium chloride plus potassium hypochlorite plus water. Now, if excess chlorine is bubbled through hot concentrated solutions of the caustic alkalis, the chlorates are chlorates are formed. We are talking about the sodium chlorates and the potassium chlorates. As we can see from the reactions, the sodium hydroxide plus the chlorine leads to this sodium chloride plus this is sodium chlorate plus water. The same goes also to the potassium hydroxide uh, leads plus this sodium plus chlorine leads to the potassium chloride plus potassium chlorate plus water. Now, the caustic alkalis are strong bases, which means that they react with alkalis by the neutralization reactions. So, neutralization reactions here specifically, as you can see here from the example, the sodium hydroxide plus the hydrochloric acid leads to the sodium chloride plus water. The same goes to the potassium hydroxide plus the sulfuric acid leads to this potassium sulfate plus water. Now, let's see the chemical properties of the this calcium hydroxide. Specifically, we've already covered the chemical properties of sodium hydroxide. So let's see the chemical properties of the this calcium hydroxide, starting with the first one that is in terms of the action of heat. Now, all hydroxides except the potassium hydroxide and the sodium hydroxide decomposes under the action of heat to the oxide and the steam. So here we see that the calcium hydroxide also undergoes this thermal decomposition to calcium oxide plus steam. As you can see here, this thermal decomposition of this the calcium hydroxide leads to the calcium oxide plus uh, plus gas. I hope that's clear. Now let's see the reaction with acids. Now the calcium hydroxide it dissolves readily with the dilute hydrochloric acid and the nitric acid from the corresponding calcium salts. As you can see, for example, the calcium hydroxide plus the uh, hydrochloric acid leads to calcium chloride plus water. The same goes to calcium hydroxide plus this. The nitric acid leads to calcium nitrate plus water. Of that's clear. So here we've seen the chemical property of the calcium hydroxide in terms of the reaction with the acids. Now, if the reaction with the dilute sulfuric acid is unsatisfactory due to the formation of the calcium sulfate, which it tends to precipitate on any dissolved lime. So that's how it is. Now let's move on to the reaction with the carbon dioxide. Now a solution of calcium hydroxide in water is called the lime water. Now the calcium this carbon dioxide it turns lime water milky due to the precipitation of the white particles of the sodium, I mean of the calcium carbonate. As you can see in the reaction, this calcium hydroxide plus carbon dioxide gas is this calcium carbonate plus water. These are the solid particles formed. Now, reaction with the ammonium salts. Any ammonium salt will increase ammonia gas when heated with the calcium hydroxide solution. Now, this is the common laboratory method for the preparation of the ammonia gas. As we can see in the reaction, the calcium hydroxide plus this ammonium is to this ammonia gas plus the calcium chloride plus the water. Ironically, you can see how the ironically this reaction how it occurs. Now, reaction with the chlorine. In terms of reaction with chlorine, when chlorine gas is passed over moist or the solid calcium hydroxide, bleaching powder is what is formed. Now, the formula of the bleaching powder is complex and is known with certainty, but it's probably containing the calcium ions, chlorine ions, and the hydroxide ions and water. The reaction equation for the formation is usually written in the approximate form. As you can see here, calcium hydroxide plus chlorine gas leads to this calcium, this formula, this is the bleaching powder plus the water. So that's clear. Now the accepted but highly approximate formula of the bleaching powder is this one, as you can see. So this is the approximate formula of the bleaching powder. Now, it is known to contain a mixture of the calcium hypochlorite and basic calcium chloride. So this is what it contains, this the bleaching powder. Now, when chlorine gas is bubbled in a cold milk of lime, a mixture of the calcium chloride and the calcium hypochlorite is formed. As you can see in the reaction, when this calcium hydroxide reacts with the chlorine gas, this calcium chloride plus calcium uh, hypochlorite plus water. Now, when chlorine is bubbled through hot milk of lime, we said that the calcium chloride and the calcium chlorate are formed, the same as you can see in the reaction. Calcium hydroxide plus chlorine leads to the calcium chloride plus calcium chlorate plus water. Now, let's see the reaction with the hydrogen carbonates. Calcium hydroxide, it removes the temporary hardness of water by precipitating the carbonate form from the hydrogen carbonate. As you can see in the reaction, calcium hydrogen carbonate plus calcium hydroxide leads to calcium carbonate plus this water. So the calcium hydroxide, it removes the temporary hardness, and the temporary hardness can be caused by the calcium hydrogen carbonate. So after so clear, we've discussed the various chemical properties of various compounds. Some of them we've seen the properties of calcium hydroxide and the chemical properties of the sodium hydroxide. That's so clear, and thank you.